but there's one that I don't understand, and so I couldn't find it in the book either. So
Okay. Would you like to share your screen and then I'll work on it tomorrow and then I'll email. Would that be okay?
yeah, it's totally fine. Um, so anyways, this is kind of what I came up with. These ones are really easier just because you just have to know like what the y-intercept and the slope are in here. Of course, it's 2.0 is the y-intercept and 1.5 is the slope in in the simple linear regression equation. It's just kind of like algebra, kind of almost. And the book they kind of use differently. It's like
Okay.
y hat equals that. So 2.0 would always be the y-intercept. 2.0 would always be the y-intercept, and then 1.5 would always be the slope.
Okay.
Does that make sense? All right. So in the book, it talks about. Remember in algebra that y equals mx plus b.
Yeah.
So m.
The formula at the beginning of the chapter, right?
It talks about the
You
m.
have the. Oh, there it is. It's up. Yeah.
It talks about it up here,
All
where
right.
m is the slope and b is the y-intercept.
Uh huh.
They use it differently in statistics. So what they use in statistics is that we represent, it starts right here, right here. We represent the y-intercept with a symbol BO and the slope with a symbol B1. In addition, we often write the y-intercept as the first part of the equation. Kind of weird. I was like, sure, that makes total sense to me. Why would this be the y-intercept and this be the slope when in addition you also write the y-intercept as the first part of the equation? So you kind of do, basically, you always write the y-intercept as the first part of the equation, which is this BO. Instead of this being slope, BO is actually, or B0, sorry, B subscript 0 is the y-intercept. And then B subscript 1 is the slope. So they kind of switch it around because with algebra they use y equals mx plus b, where m is the slope and b is the y-intercept. So they basically just switch it around in statistics. Does that make sense?
Yep. It will
Okay.
be y. So 2 will be the y. So it will be the horizontal one. Or is
Yes.
that the vertical one?
2.0 would be the y-intercept. 1.5 would be the slope in statistics. Statistics uses their linear regression equation differently than algebra does. So basically, y-intercept is 2.0, and then the slope is 1.5. In algebra, the y-intercept would actually be the 1.5x, and then the slope would be
Yeah.
2.0. But in statistics, just have to memorize that 2.0 or b subscript 0 or subscript 0 is y-intercept, and then b subscript 1 x is the slope. You just have to memorize the equation like that. Anyways,
Yeah.
so yeah, that's just how you do that one. For number 5, you just have to plug in x. You plug in 16 for x. That's the predicted value. So you basically
Oh,
just take
yeah.
0.25
Yeah.
times 16 and then you take negative 3.0 plus whatever answer you get for 0.25 times 16, and that's 1.00. You have to put, I just put, it says round to 1 decimal. I could have done that. I just put the, you can just put 1.0. You'd be fine. 1.0.
Yeah, so let's see, just plug in the 16 and the x, multiply 0.25 by 16 and add it to 3.0.
Yeah.
What did it give you?
5 times 16 equals 4.
0.25 times 16 equals plus 3.0 negative 1. Yeah. So 1.00. Got it.
Yeah. You can put 1 decimal. I put 3. I was just trying to do it fast, but anyway, so yeah. So you plug in this this data file into, so this is your data file here. You download the math self-efficacy. You plug it into your explanatory and response variable. So this is kind of weird. So if you go into the quiz, it tells you be sure to use confidence data for the explanatory variable and the score data as the response variable. So when you go into the data, it puts confidence after the score. So I had to first highlight the confidence rating and put that in the explanatory, which is over here on this side. So I plugged in the confidence.
You put the confidence
data. I think that's right. Let me look at it one more time real quick. Right, so confidence data. So I plugged in the confidence data right here under X.
Okay.
And then I went back and I did the score data, which is right here. And I plugged that into the response variable, which is right here.
Okay.
Okay. Because that's how they wanted you to do it.
You did it backwards. Can I see the quiz really quick?
Definitely.
How do you know? It says be sure to explanatory data also is telling you right there. And the score data as the response variable. Okay. So you need to do it like that.
Yeah. No worries. So
of the 3 data shapes introduced in the reading, which shape best describe of the 3 data shapes.
yeah, which shape best describes these data? Okay. So when you go into here, it's gonna automatically create a which right here, it's creating a scatter plot for you.
Yeah.
So in the book, you go to the book, and you go down a little bit here, and underneath, I think it's under crocodile. Oh yeah, under the manatees, which is this right here, this manatee power boats. It gives you hot dog shape, hamburger shape, or banana shape right here. And so I just looked at these little tracks right here, and then I went back to mine, and I realized, oh, it looks like hot dog because it's all like weird and stuff. I mean, it seems like it's more centered. Yeah. Okay.
So it's the linear path.
Mm-hmm. So the next question on this.
So that's what the 3 data shapes. It comes from the book. Okay.
Right.
So the hot dog shape.
Okay. So the next one, based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data? So I went back to the book and I looked under decisions, and I noticed that under hamburger shape it says linear regression is not appropriate, and then it said linear regression is not appropriate for the banana shape, but under hot dog it says conduct regression analysis, determine if there's a significant linear relationship. So I went up in here and I was like, well, they have simple linear regression is not appropriate for this data, which is not true because under hot dog shape it doesn't say anything about that. If the simple linear regression is used for these data, the results will not be reliable. I don't think it says anything about that, so I chose the first one, and the first one was right. So simple linear regression is appropriate. And I got that from reading down here on the decision. These
So there
both state is not appropriate. But it did state that for
the hot dog shape.
So I kind of just guessed. I mean, it was right, but so luckily it was right. But I figured it would be because it wasn't the third one, and the second one didn't make any sense to me. Because I'm like, if simple integration is usually the results will not. That's almost the same as the not appropriate. These kind of run the same.
By elimination, yeah, you figure out which one's the right one. So
Right,
if simple linear for these tools will not be reliable. Simple linear regression is not appropriate for this data. Yeah.
They seem like they're the same.
Yeah, for this data. Okay.
So going on number, I didn't understand this one. So I don't know how to answer it. I only chose 142 because I went to this and I was under this and I just went all the way down to the bottom and I saw there was 142 spaces, but I don't think it's right. I could be, I'm probably way off.
Huh?
I'm like, I don't know if it wasn't right, so I don't know what this stands for. I tried to look for it in the book. I don't know if you could.
You could have, but what about 142 multiplied by 2 observations, like 242?
Yeah, but I'm wondering since it says it's 142, but you'd have to subtract like 4 from it too, because like 1, 2, 3, 4.
See, let's look at the.
It starts at here.
Oh, got it. Starts in 4.
Yeah, I don't
And it goes all the way to 142.
I tried to look in the book to what they're talking about by observations. I couldn't find anything on it. I didn't see anything that says how many observations this data had to this or whatever. Blah, blah. So I don't know what the answer is to that one. I really have no clue.
So if you take away 4 from that, it would be 138, right?
Yeah, it would be. I mean, I could try to put.
No, I haven't submitted the first one, so let me try and try. So 138 multiplied by 2. Would you consider an observation like each one in both groups or just one group? Because I'm thinking it would be both groups. It's like each data you observe or that you there too, like if you go to the book, then you can see if in the book they use that terminology, like observation as just 2 groups. We observe 2 groups. They ask you 3 questions like that.
I know what you're talking about. It makes sense that whatever. I mean, you could put 276. That's what you came up with, right? 276.
Yeah. But let me see.
Right.
Can you see anything in the chat?
What's that?
Do you see anything on the book that talks about observing? I'm looking at it.
Yeah, I'm trying to. I tried to read through it.
So one number is the so Y is like one group, X is another group. The answer could be just 2.
I know, it could be. It could be just 2. That's why I'm like, well, maybe we should just put 2. So I don't know. I'm guessing I might put 2. I don't know. I know after tomorrow or something, she'll put the right answers on there, and we'll know what the right answers are. But
Okay, let me go back to your, stop looking at your thing. Okay, so you're 8, 9, what is the y-intercept? So how do you get that? 690. Didn't you say the y-intercept is the...
yeah, so you plug that data in, the y-intercept comes up as
equation? But you got that one
18.69.
there, right? Yeah.
What's that? Yeah.
So the
So I use
y-intercept, oh, it's right there. This is the b. And the slope is 12.60 something.
4.695.
Well, that was easy. It's just a matter of understanding the Excel.
That's right. Mm-hmm.
And then what is I when x equals 4? So do you use the formula, or it's just in the Excel?
Yeah, you can do it in Excel. So you just go in here and you go under X and you put in 4 and it'll change your number. It's 69.469, which is this number right here.
69.469. Just plug in the x, and it's right there for you. Perfecto.
And this one I kind of had to sit for a while and think about. I'm like, well, it said the confidence data resulted from students evaluating their competence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? And I give you a hint, right? So because there's positive correlation, we can use the largest x value to find the largest predicted value of y. So it's this, you put this number in, 6, and then it'll change your number. You get 94.859.
Can you go back to the quiz really quick?
Yep.
The confidence that results from students on a scale 1 to 6, and so you just grab the maximum number, like highest number.
Yeah, scale 1 to 6.
5 for the values of okay. See, I wouldn't know how to do that one.
I know, it was
Okay,
kind of
so
weird. It was kind of weird. What I actually did was interesting. So what I did is I took the explanatory variable, the x variable, and then I actually brought it down here and sorted it, went to the bottom of this, and found that the maximum variable was 6, and that's when I plugged it in and got that answer. That's how I got 94.859.
Oh.
That's what I did, because I wasn't for sure how to do it. And then I looked at the question again, but it said on a scale of 1 to 6, and then they wanted the max, the largest x value, which was 6. I was like, oh, okay. That makes sense.
There is a positive correlation between the largest x value to find the largest predicted due to the largest number. Okay.
Yeah. The largest.
So I'll put right here x6, x4. Writing notes. 13. How many explanatory independent variables are present in a simple linear regression? More than one, or two. And that's in the book.
Yeah, so if you look in the book, it says this. Where did I even read this at? On the top, maybe?
Where is it?
I'm looking for it right now. Where did I read that? I read it up somewhere. Friends practical.
It was somewhere. There's no there.
Hold on, let me go down here more. I'm just trying to read where I'm trying to figure out where I even read it. I'm sorry, I'm trying to find it here. I remember reading it.
At the very end. No, use more than one predictor to learn. Nobody we want to predict. What was the question?
It's how many explanatory independent variables are present in there, and then how many response.
How many explanatory independent variables are present?
You basically have 1 and 1 because if you look at the data, you have an explanatory variable, which is 1, then you have a response variable, which is 1. So this is 1, this is 1.
Oh.
But
Can I see your quiz really quick?
Yeah.
How many explanatory variables are present? One. How many response? 1, 2, right? That's the answer of 14. 1, 2.
Yeah, that's what.
So 1 for each.
Yeah.
Yeah.
Which would make up 2.
Okay.
And the last one, I got wrong, but I was like, the measurements they collect include hat size, circumference of the hat, the length of the major and minor axes, which I don't think matter. So it says, meaning the company wants to predict size of hat given the circumference. What is the response variable?
Johnny. The companies that auto manufactures hard hats used in the mining industry. They record measurements on all for quality control and planning purposes. The measurements they collect include the hat size, circumference of the hat, length of the major and minor axis. The company wants to predict size of hat given the circumference. What is the response variable? The size of the hat, because it is variable being predicted. What's the first one?
So I was just like, well, we got to mean the company wants to predict the size of the hat given the
Response variable is the variable of which you ask the question.
Yeah, the response variable, so it's weird. So if you go all the way to the top here, it talks about, so they use a kernel. So the independent variable is the head length, and you will use this to predict the dependent variable. Like for right here, this is where they talk about the crocodile they use. Sorry, I'm tired. They use the head length, which is the independent variable, which is x value, to figure out the dependent variable, which the dependent is the response variable. So they want to know the dependent variable that helps.
The response variable is the focus of a question in a study or experiment.
So going back to here, I was looking at this and all right, so wants to predict size of hat given the circumference. What is the response variable? Not the
Read the
circumference.
question again. A company
So
South
it's going to be
America.
the size of the hat.
The company in South Dakota manufactures hard hats, core measurements in all the hats they produce for quality control planning purposes. The measurements they collect include hat size, circumference of the hat, and the company wants to predict size of hat given the circumference. So I'm thinking it's number 3. The size of hat is predict the circumference. Because here it says the response of a question in a study or experiment. They're focusing on the size of the hat. The explanatory variable is one that in the variable.
Mm-hmm.
So it is being used to experiment. The size of the hat is used. So let me try that. And let me submit my quiz, and I can share my screen now so you can see what I'm doing. There you are. She's not full asleep. Hold on. There. Okay, so 3 was 2.0. 4 was 1.5. Oh, actually, it has 3 decimals, right?
No, you can round to 1.
Yeah. 1.5. 5. 1.00. Say, that's my husband. Hot dog. 7. Simple mirror. How many observations are in the data? Should I try number 2 or the 276 or the 138?
No, I really have no clue. I mean, you could try 2 if you want to. It's up to you. I don't know, because I mean,
I can submit the quiz 2 times, so we can. How many observations? I was just gonna put 276. It's like the total of the whole thing.
okay.
Oh my. Okay, I'll try that one. And then nice 18.960. 10 is
Oh,
12.95. Is that correct? 12.695.
number 10. Number 9.
Is that correct?
Number 9.
1890.
Number 9 is 690, not 960.
Oh, okay. I was gonna tell you that I have. So 18690.
Yeah, there you go.
Okay, and then 11.469.
Yeah.
Is that right?
No, you're fine.
Of yeah, just make sure I'm writing it right. 859.
Okay.
Is that right?
Yep.
1, 1, and then that one. Okay. Need to go down. Okay, I'm trying to submit it like without the way. Still wrong. Number 8.
Yeah,
Still wrong.
it's not that one either.
Right one. So size of hat. So it has to be number 1 then. The size of the hat because
I'm gonna try number one myself.
number 8,
Uh,
really observations. How do you determine that though?
I don't know. They don't tell you in the book how to do it at all, and so I'm like, okay, cool. Maybe it's from an older chapter. I looked at 21, but that was kind of weird.
Okay, I'm taking it again too. Try the number 1 on the last one, or you want me to try? I don't.
I'll try. Let me do it, and then I want to make sure you get it right.
I'm curious about the observation one. I wonder if it's just as simple as two groups.
I mean, what do I got to lose? I get a 90 instead of an 80.
I don't think it has to do with
It doesn't make my grade go up more than where I'm at anyway. I think I'll pass this.
With the information. It says given, where is it? How many observations? It says for the next 7 questions, use this data. Be sure to use the confident data. Okay, make a scatter plot of the 3 data shapes. Yeah, based on the shape. So it doesn't talk about the observations when they introduce the problem. They may just do 2 groups. This test. Yeah, I'm confused about that one. Uh,
All right, so not 2 either. So I don't know what it is, but the last one is the first one. Number 15 is the size of the hat because of the variables being.
because the variable is being, because it is the variable.
It is the variable being. So that one's the right. That number 15 is the first one, number 1. But I don't know. I don't know what the observations are. I don't know what that is.
For 8. What do you
don't know the answer.
do?
I wish you could trust this.
Sorry, I couldn't hear you. Do you put number 2 on number 8?
I did. It's not right.
And it's not? Ay, ay, ay. How many observations? Come on. See if I add them all. I'm going in my Excel. Hold on. They are 50. Is what it says on my. It says 50. Oh no, 50 is the first number. Um. So one is the score, and the other one is the confidence. Wait, am I in the right document? Yeah, right? It's the math self-efficacy.
Yeah, you're in the right one.
Confidence rating mean, and this would be the mean. So that's a calculation from this.
Yeah.
Maybe, I don't know. So from 2 to,
Unless the observations is the sample size, but then I'm like,
that would be the sample size. 139.
yeah.
Okay.
I have no clue. I mean, or maybe Alyssa knows, but she's not here tonight, so I'll have to ask her what she got. Because it doesn't tell you the book. So why would, I mean, technically, I've been, at least I've been looking at the book for a while, unless it's like in a different chapter, but then, that's how
Yeah,
the
but it
statistics.
just, it's the N equals just the amount of observation. Doesn't
But
sound like.
the group, like when usually it's the group quiz, it's from that.
That's what it was. So 139.
It was
Can
that
you
right?
start? So
So
139. Yeah.
okay, 139. So it's a
Just
sample.
yeah. So just this one here. Remember, the first one was the name.
I just want to. Okay, well, at least we know what it is now.
Yeah, it was 139. Tricky. Trickers.
Awesome. Okay. Let's see.
Okay. So what is it? I hope I don't mess up on that. Let me go. What I need to do for the. Let me open that document.
Yeah, go for it. The one I sent you?
You want to talk about this now, or should we just meet a different day?
Well, we could either meet. I mean, this is for. I'm trying to remember. So she.
For that paper, I have to turn in. But she said she already did it, so
She mostly did it all.
I don't know. I don't even know what
I don't. Get that all. Open up the document she has. Do you have it? I made a Google Doc, but it doesn't. It's not working really well, so I'm gonna have to fix it. But if you open up the
Which one should I open? This one, right? Final project?
Yeah, open that one. Try. See if that works. You can open that one if you want to. I need to put something else in there. Let me see if I can get this in there because I'm having a hard time getting that.
So what do I need to do? So this is what I need to turn in, and when I turn it in, I have to. It's just one page, 2 pages. Oh, I'm sorry, making friends. Title of this assignment. So I have to answer.
Let me do something on this Google Doc really quick. Hold on a second, okay? I'm trying to remember where I need to put this data. Right above studying. And put these things in there now too. You see them? What? So this is what Alyssa did. Research question. We were trying to determine if children between ages 6 and 12. Of course, that's what it is, right? So basically, what we have to do is these directions. Your document should include the following. So there's the title, which you just put in there. The names of all the members, that's us. The research question, we got that. The name of the hypothesis you choose to use, I think. You put that in there. One sample.
So where has it before?
What's that? I'm sorry?
Like the one that where I edit, is that in my email too? What am I missing?
Are you looking for the one Anna sent you? Anna sent you a document through your email. The one in Google Docs, I just kind of open it so we can all see it together and stuff, like the same thing of what she had on hers. She should have sent you something. Let's see. She should have sent you something earlier.
So I don't have it here in my home mail. Is that what's happening?
I don't see it in there. That's kind of weird.
Is the one I open here? This is one. Why is this sad? Her brother.
Yeah, this is the one Anna sent. Or Alyssa
Okay, so
sent to us this morning. This is everything. I also made it a Google Doc, so it's up to you what you want to do. You can actually do this straight document that she made right here. And basically, she's pretty much done everything. And going through the directions, this is, I think the name of the hypothesis test we chose to use was this is the summary statistics. But she put that on there. She put our null hypothesis. She put all that on there. So she did 1-2 paragraphs testing whether or not your data meets requirements. Nope, that's in there too. Okay.
Title of this assignment.
She did the QQ plot.
That's right there. Title of this, okay. The names of all the members in your group, include your group names. What do you mean number? Oh, name of group 2 members. So is that the number? Group 2?
Include your group name and number. Yeah, so we're group 2. Those are our names. We're our group 2. Yep.
Question. Your research question.
You put that in there.
That's right there. We're trying to determine if children between the ages of 6 and 12 need to be prompted to brush their teeth more than for the. Okay, check mark. Number 4, the name of the hypothesis test you choose to use.
She did that. It's right there.
Hypothesis test 1 sample t-test for means. Okay, so that's number 4. 5, 1 or 2 paragraphs discussing whether or not your details meet requirements for your hypothesis test. If you use QQ plots or box plot, include those in your document with explanations. So write out any formula show you that it meets the requirements. That's number 5.
She did the differential statement. If you go down a little further in the document, she just puts she gives in our study of asking parents to count the prompts, takes the effort to brush your teeth. Quick response that shows basically you're 95% confident in true mean. And her response that takes the so she puts in there all that, including the paragraph for the QQ plot. So number 5 should be done for that one too.
Yeah, so where is that? Where are you?
Just go down a little bit farther.
Is it here in the first page? No.
Yeah, go down a little bit farther.
Okay.
she writes it underneath this sample one right here. Right here it says, in our study of asking parents to count the problems it takes to get the children to brush their teeth. Under here, she writes her null hypothesis. In conclusion, based on the results of the study, parents should prepare their kids to brush their teeth more than one time. So everything's in there for number 5.
So that will count as number 5?
Yes.
Okay.
There
The
should.
alternative hypothesis.
They also states that write out any formulas you're using to show that your data meets the requirements.
Uh-huh.
So, looking at this, let's see here. Any formulas.
See there? I remember doing that.
Yeah. Find it.
And
I mean, the only formula that she's actually using is this one sample t-test for means. Like this actual summary statistics. I mean, I don't know for our thing.
the p-value on t-statistic here. Do we have to write it down too, or it's just evident here in the Excel?
Technically, it's already in the Excel doc, in the Excel
Yeah, right.
snippet that she did for that. So I feel like 5 is pretty much satisfied. 6 is satisfied. She satisfied number 7, number 8, and number 9. And I think number 10 as well. I think she just did it all.
Yeah. Should I just do that? Let's just do it. What do you think?
What's that?
Should I just submit it like that?
All right.
We're too tired. Let's just do it.
One of these things here, so.
Huh?
I mean, let's see here. Perhaps like your reduction. Let's see here.
Okay, so how do I save this on my computer? Oh, it won't manage.
Save this to
Okay.
your computer. Just go up to. You just pull it over into. You want to go over to this little box up here and download it.
Descargar, and then here.
Yeah. There you go.
I'm not gonna make any changes on that document. I think it looks good. Unless you tell me make this part better tomorrow.
We could email. I'll email her and ask her if there's anything else we really need to add to it and see what she thinks. Because it looks good to me. I mean, if you look at, let's see, is it number 12 right here on here? Rule number 12. It says 1 to 2 paragraphs describing the action you would suggest based on the results of your study. I mean, down here she mentions, based on the results of the study, parents should prompt their kids to brush teeth more than one time. Parents would like to see a reduction in their problems. She gives questions there too. So I feel like she just did the whole thing. You know, I feel like it's a good document, but I can email her and ask her to make sure.
Should I delete this first page and just
No,
leave this?
actually, I turned everything in last week with the directions on it. I didn't even bother because I think it helps the teacher see.
To know that
Yeah, just make sure everything's in there. But if you want to just turn it in like this, I think I'd be okay with it myself. It looks like it's done. It's kind of interesting because with our study, we kind of just took everything from last week and just put it into this document for this week. I guess you do like a spell check and do some other stuff just to make sure it's all right.
Coma. ways we can take, we can act. No, that's right. Just ignore that. No, ¿qué pasó, mami? Okay. It's edit, except for your last name.
Yeah, my last name's always wrong. Don't worry about it.
Nor all. Okay, I think that's it. So I'm saving. Okay, so you guys just tell me when you want me to turn it.
I'll email her.
Make any other changes.
I'll let you know tomorrow.
Let me put that in. Where is it though? If I minimize it, it's called making payments. Documents or downloads. Making payments. Yep. So I have it saved. Okay. Yeah.
Okay. Sounds good. I'm gonna go post this video on the discussion board and everything, and then appreciate you meeting. I'll email you tomorrow about
Yeah, let me know, and then I'll submit it. If she wants to make another change, but I think it's fine just like that. I wouldn't add anything else.
Yeah, I agree.
Today's